What is Frenkel defect? Let us understand Frenkel defect by observing the structure of ionic crystal shown. Let small ion, namely cation, say A+, leave their original lattice site and occupies the interstitial site of neighboring ions. This leaving of cation from its lattice point generates a gap or a hole, and this in turn creates a defect in ionic crystal, which is called as Frenkel defect. One Frenkel defect creates one vacancy and one interstitial defect caused due to occupation of cation in interstitial site. Since the defect is caused by dislocation of cation from its lattice point, Frenkel defect is also called as dislocation defect. Frenkel defects are common among ionic compounds with low coordination number and in crystals having large ionic differences between cations and anions. Ionic compounds such as zinc sulfide, silver chloride, silver bromide, etc. show Frenkel defect. Consequences of Frenkel defect. The number of cations and anions in ionic crystal remains the same before and after Frenkel defect. Before Frenkel defect, the ionic crystal shown has got 10 A+ cations and 10 B- anions, while after Frenkel defect, due to dislocation of cation A+, the number of cations and anions remains the same, that is equals to 10. The density of ionic crystal before and after Frenkel defect remains the same and does not change. This is because in Frenkel defect, the cation lies in the interstitial site without leaving the ionic crystal. Since in Frenkel defect there is no change in density, even though after dislocation of cation, it is also called as dislocation defect. In Frenkel defect, since the cations are closely arranged, this increases the dielectric constant of the crystal.